Hey all, this is Anjali and today we're going to do binary search trees. Binary search tree is a very important thing in data structures as it facilitates the searching procedure, it makes it faster and it provides us hierarchical arrangement of data. So whenever we talk about trees, that means the data is not in a linear form. The data is in a non-linear form. We have one parent, then you have subnodes of that, then you have further subnodes of that. So we have trees categorized as binary trees or M-way trees. So first we'll discuss about binary trees. Binary means two. So the word binary itself says that a tree which can have maximum of two subnodes can be called as a binary tree. So a binary tree will have a node which will have two subtrees, one on the left side like this and one on the right side. So there would be a left subtree for every node which can be null if there is no left subtree available. There would be a right subtree for a node, and in case there is no right subnode, it should be null. So a binary tree has three things in every data element, that is the data to be stored, a pointer which will store the address of the left subtree, and a pointer which will store the address of the right subtree. So that makes a node structure for a binary tree. You can see over here, this is a sample tree. The arrows in black shows the connection in the tree. The green arrows are just to depict like what the nodes are. So you can see over here that we have node A, that is the root from where the tree starts. Then it has two subnodes. The left subnode is node B and the right subnode is node C. These nodes are called siblings since they are on the same level. So the nodes on the same level are called siblings. Then further we have subnodes for B, that is D and E, and a subnode for C, that is F. So these are further level siblings. So we start from here. This is level 0. Like this is level 1, level 2, level 3 and level 4. And height of the tree is counted as the total number of levels in the tree. So the number of levels in this tree are 5. So we'll say that height of the tree is 5. These nodes which have further subnodes are also called as internal nodes. So A, B, C, F and G, these are internal nodes. But the nodes which do not have any further subnode, like D does not have any subnode, E, I, J and H. So these nodes are called leaf nodes or external nodes. So the leaf nodes means the ones which does not have a further edge ahead. So that's a binary tree. So any kind of hierarchical arrangement where we cannot have more than two subnodes, that is there would be either 0, 1 or 2 subnodes, that's called binary tree. So we can see the basic structure of a binary tree. If my tree is like this, that I have node A at the root, then I have B on left, C on right, then I have D on B's left and E on B's right and C on F's right. So that would be shown like this, that we have node A, that is the data. Then we'll store the address of the node B, which is the left child for A. Then address of node C over here in the right child. Then similarly, B stores the address of D on the left, address of E on the right. And further, the D1 stores null on the left, null on the right because there is no further subnode. Same way, E stores null on both sides because there is no further subnode. In case of C, we have a right child, but we don't have a left child, so left is null. And over here again, F has both nulls because there is nothing after F in the tree. So this is the basic binary tree structure. We have various type of binary trees. We will be discussing later that we have complete binary tree, we have heap, we have threaded trees, and most important, we have binary search trees. So in this lecture, we will be covering only binary search trees and specifically insertion in a binary search tree. So first of all, let's discuss what binary search tree is. Now we have done the algorithm binary search when we do arrays. We've done how can we search an element in an array using a binary search algorithm. If you remember, the basic thing in binary search is that we get the midpoint. We find out a midpoint in searching, and then from that midpoint we check that if the number to be searched is greater than the middle element, means it lies on the right hand side, and if it is less than the middle element, it lies on the first half. So that means Depending upon the number greater or less, we decide which half we have to choose to move further. Same way in binary search tree, we have a node and we have a rule that whenever a value has to be inserted, a greater value will be inserted on the right hand side and a smaller value will be inserted on the left hand side. So that simple is the rule. We will be inserting one value at a time, and as the values get inserted, we have to check every time about this greater than less than thing, and accordingly we decide the position where an element should be inserted in the binary search tree. Like you can see here, we have root as 8, 11 is greater than that, 5 is less than that. Then these 2 and 4, these are less than 5, but 4 is on the right of 2 because it is greater than 2. Then again 6 and 7 both are greater than 5, but 6 is on the right side of 5 and 7 is on the right side of 6. On this side, 11, 9, 10, 12, 14, 13, every number is greater than 8. That's for sure. That's why it's on the right hand side of the 8. Now here, 10 and 9 are less than 11, so they are on the left. 9 is on the left of 10 since it is less than 9. And similarly, this side. So that's a binary search tree, and a very important thing is that duplicate values are not allowed in a binary search tree. If I already have 10, I cannot insert 10 again. It's not allowed. So we cannot have duplicate values in a binary search tree. So we will be covering these operations. That is, how do we insert a value in the binary search tree? How do we traverse it? Traverse means how do you process each element exactly one? How do we search for a value? How do we delete an element from a binary search tree? To find the maximum and minimum number out of the tree, to find height of the tree, and to get the mirror image of the tree. In this lecture, I'll be covering insertion. So let's see how insertion is performed in a binary search tree. Let's say we have these numbers given and I have to insert them in a binary search tree. So the first number which we have becomes the root. So we'll go step by step. Let's pick up the first number, 80. That becomes my root. So whatever the number is, because when you have the first number, there is nothing to be compared with. So we take the first number as the root. So this becomes the root. Okay. Now the next number we have to insert is 56 in the list. Now this 56, I'll check whether 56 is greater or less than 80. It is less than 80. So it should be inserted on the left of 80. So it gets inserted on the left. Then the next number we have is 97. Again, I check it with 80. It is greater. So it should be inserted on the right. So my tree looks like this. So we've got 97 on the right of 80, 56 on the left of 80. Now the next number I have is 92. We have to start checking always from the root. So we'll check with 80. 92 is greater than 80. So means it should come over here on the right hand side. But I already have something on the right. 97 is already there. What should I do? Now I'll check this 92 with 97. It is less than 97. So it would be inserted on the left of 97. So we insert it as soon as we get the condition true and we get a place. That means its left or right should be null so that we can insert it over there. So 97's left was blank, so I could insert 92 over there. So that's how we can insert 92. The next number comes as 13. 13 will be inserted on the left of 56. Now why? First of all, 13 is checked with 80. It is less. Okay, we check the left side. There is already 56. So we need to compare 13 with 56. Now 13 is less than 56. So it's inserted on the left of 56. So that's how 13 finds its place. Then the next number is 67. Now 67, again we start comparing from 80. It is less than 80. So we move on to 56. It is not less than 56, rather it's greater. So it should be inserted on the right side of 56 since it was blank. So 67 gets inserted here. Now the next number we have is 50. Okay, again we have to start from 80. Now you check if 50 is less or greater than 80. It is less, right? That means we need to insert it on the left hand side. But on left you already have 56. So we can't insert here. Now we'll compare it with 56. Now 50 is less than 56, true. So we go to the left, but left is not blank. There is already 13. Now we need to compare this 50 with 13. And it is greater than 13. So we insert it on the right hand side. So it gets inserted over here on the right. So that's how 50 finds its place in the binary search tree. Hope you understood how the values are getting inserted. So main thing is to check whether the value is greater or less, and depending on that we have to decide whether it has to go to the right side or the left side. That is the basic key behind inserting an element in a binary search tree. Now this is the basic logic. If you have understood this, then we'll go for the algorithm part. If you haven't understood this, then please follow the previous slides again so that you can understand how I'm inserting the values in the binary search tree. If you're clear with it, let's go for the algorithm for insertion. Now we assume that we have root as a pointer which stores the address of the topmost value. Then we have a value to be inserted, and the structure of the node is like we have a data part, we have a pointer left which stores the address of the left subnode, we have a pointer right which stores the address of the right subnode. Now how do we work with it? Initially, wherever the number has to be inserted, it should be allocated memory at least. So I allocate the memory to a pointer named temp. So I write set temp is equal to avail. This is kind of pseudocode. This is no specific programming language. First, we'll be discussing this algorithm and then we'll code it in different languages like C, C++, and Java. So first of all, understand the basic concept, what we want to do. So what we want to do is we want to allocate memory dynamically for one node, and whatever value we have got, we store it in the data part of that node. The new node will have no subnodes, that's why its left will be initially null, its right will be initially null. So these four lines, step 1, 2, 3, 4, are basically used to create a new node which has that value which we need to insert in the binary search tree. So my node is created with these four statements. It is done. Now I need to check if root is null. If root is null, that means there is no tree right now. So this node, this new node should become the root itself. So we put temp in the root. So set root is equal to temp. So this first node becomes the root, and then we have to stop. We stop the function. We don't go further. Like in the previous example, when 80 was there, so memory is allocated, 80 gets stored in data, its parts, left and right parts are null. And if root is equal to null is true, so the address of 80 goes to the pointer root and it stops. So 80 is inserted as root in the table and the further code will not work. Now let's say the second value comes, that was 56. Okay, it comes here. It again creates the node is created, but this time this condition is going to be false because we already have a node at root. So it comes at step 6 where we initialize a pointer ptr with the root, and then we have a loop. We have a loop which will help us find the correct position where we need to insert the node. So we have to repeat till ptr is not equal to null. What I check over here? I check if the value to be inserted is greater than ptr data. If it is greater, that means where it should be inserted? Yes, it should be inserted on the right side. It should be inserted on the right side, but for that, right side should be blank. Then we check if ptr right is equal to null. If it is null, means you found the position. Good enough. I just put the address of temp in the ptr right and end. That's it. I've got the location. I established the link and it's over. But there is a possibility that there is already a value at the right hand side. If there is already a value at the right hand side, then we just move to that node. We move to that node by writing this line ptr is equal to ptr right. So your pointer goes one node down towards the right hand side and the loop will continue again. And it will again check whether the value to be inserted is now greater than or less than the new location of the pointer. If it is not greater, the same thing is checked if the value is less than ptr data. If it is less, it should be inserted on the left hand side. For that, we need to check if ptr left is equal to null. If yes, we have found the position. We insert the node, we link the node with the help of this line that ptr left is equal to temp. So temp gets linked with the node and we stop. Otherwise, we move the pointer to the left side. We come down the tree on the left hand side and then the loop is repeated again. Now, if it is not greater, it's not less, the values are same. So as we discussed, the duplicate values are not allowed in a binary search tree. So we just print that duplicate data is not allowed and we stop the loop. And this is the end repeat thing, means all these statements are repeated till the time either we find the position where the node has to be inserted or it concludes that it's duplicate value. So it'll keep working like this. Let's discuss with the numbers. Like we inserted 80, now the next number was 56, okay? Now 56, root is equal to null is false. So it comes here, PTR points to 80, it checks, repeat till PTR is not equal to null, true. Now 56 greater than 80 is false. So it comes here and checks value less than PTR data. Yes, 56 less than 80 is true. Then it checks PTR left is equal to null. Yes, 86 left is null. So temp, that is 56, goes to 80's left and then exit. That is how it works. Now let's say the next number is 25. I have inserted 80, I have inserted 56. Now when 25 comes, memory is allocated, root is not null, so we come here, pointer is pointing to 80, it's not null. We check whether 25 is greater than 80, no. Then it checks whether 25 is less than 80, yes, it's true. Then we check if PTR left is equal to null, no. There we already have 56. So this condition becomes false. So it goes to this else part where we have written PTR is equal to PTR left. Now PTR is already at 80 right now. PTR left is 56. So this statement will move PTR to 56 and the loop will be repeated. The loop is repeated. We come back over here. It checks. Repeat till PTR not equal to null. 56 is not equal to null. It checks if 25 is greater than 56. No. Then it checks if 25 is less than 56. Yes, true. Is PTR left null? Yes, true. So 25 is inserted on the left of 56. So like this, you can try doing this dry run of yourself with different values. It will give you a better understanding how the algorithm is working to insert values in a binary search tree. So that's how we perform insertion in a binary search tree. This is the basic algorithm. In the coming lectures, I will explain you how we code for it in Java, C and C++. Hope you understood the basic concept of insertion in a binary search tree. In case of any doubts, do write in the comment section below. I'll get back to you. And if you like the video, then don't forget to hit the like button and share with your friends. And yes, do subscribe the channel. Thank you.